This is Physics 2211, Lab 1, constant velocity. Constant velocity means that the change in velocity is zero and therefore the acceleration is zero. And since acceleration is equal to zero, the net force must be equal to zero as well, according to the definition of force, which is F equals ma. The purpose of this experiment will be showing that if no net forces are acting upon a system, then the system will stay in its current state of motion/rest, or as in our case, motion. This will be demonstrated by observing a disk rolling across the floor with no net force acting upon it, and will support Newton's second law. As for the physics principles and methods used in this experiment, we'll be using a model of a disk rolling across the floor at a constant velocity for a duration of 0.767 seconds. The principle is if no net force acts upon a system, that system will continue in its current state of motion, whether that be motion or rest. The methods used are tracker, which is used to quantify the change in position of the object by determining the position frame by frame, flow script, which is used to computationally iterate in order to predict the motion of the system, and Excel, which was used to graph both the quantities of the observed motion as well as the quantities of the predicted motion. As for Newton's second law, which is also known as the momentum principle, it states that the net force experienced by a system is equal to the system's change in momentum over the change in time. The position update formula as well as the velocity update formula are derived from this principle and will be used in the glow script code. For our observed model, we used tracker. The system is the disk and the surroundings would be everything else, for example, the floor. The initial position would be the origin. The initial velocity is 0.287 meters per second in the positive x direction. The time interval would be 0 to 0.767 seconds. The net force would be zero, and we're assuming that friction and drag are negligible, so therefore would have no effect on the overall net force. As for our predicted model, we used glow script code. So we set our initial conditions, such as the mass, the position, which is zero, and the initial velocity. Then we edit our delta t, which is how many frames per second our video is shot in. This value is obtained from tracker. For example, my delta t was 0.033 seconds. Since there is no net force, the velocity should not be changing. So ball dot velocity is unchanging as well. Ball dot position will be changing according to the position update formula, and we advance the clock by taking another incremental time step of delta t. Here is the results of both our observed and predicted models. As we can see, they are very similar and correlated both positively. So what if we switched the axes since we were able to choose? So even if you were to flip the axes, the data would still yield the same exact results. There'd still be a positive increase in position over time, just in a different direction, and therefore the relationship between change in position over time, which is velocity, would still be constant. So what exactly does this mean? Is it actually possible for us to just assume that force is zero? Well, when using glow script to predict the motion, we set the net force to zero because we assume that forces such as friction and drag that act on the system are negligible. Although these forces aren't really negligible, they don't have a large enough effect to really alter the relationship we're trying to observe. This is why we observe such a nice correlation between the predicted and observed data as displayed in the previous figure. As for conclusions, the similarity shown in the figure between the results of both the observed and predicted methods align with the ideas of Newton's second law. Possible error that could have been experienced in this experiment is the force of friction and drag aren't truly negligible. There is a net force acting on the rolling disk, even if it is small. To decrease this error, the experiment could be repeated with a system and surroundings that would have less friction. For example, we could use a Teflon-coated surface to roll the system across, which would minimize the force of friction. And as for the air resistance, the experiment could be performed in a vacuum to completely eliminate the force of drag, and this would overall provide a more accurate scenario of zero net force.